Assalamu alaikum. In this class is a follow-up of the last class, which is where we discuss about the convolution code. Here we will actually discuss about the example of the convolution code. Okay, so example of convolution code. So again, let us consider a bit sequence. So consider a bit sequence, which is this 1 0 1 1 0 0 1 0 1 1. So previously we give it a name, right? So for example, this is x0, this is x1, this is x2, like this way, x3, x4, x5, all the way. So we know from our convolution formula that, for example, C0 convolution 0 for time instance j is nothing but a xj plus xj minus 2. Here this is the binary field arithmetic, right? Or binary field addition. This is nothing but the binary field addition. Binary field addition. We have already discussed about the properties of this binary field arithmetic, right? So let's because we already know the formula for C0 and C1, so there is an bit sequence given. Let us generate C0. So C0 j 8xj dot plus x j minus 2, right? So x, so we will like to have x C0 0, for example. So what we have, x 0 dot x minus 2, right? Here the value j becomes 0, because it's 0. So what is x0? This is x0. This is 1. X0 is 1 plus x minus 2. Okay, so here no x minus 2 value is given. So because this is an initiation, so we'll assume that x minus 2 equal to 0 as an initial value. So we will assume its value is 0. 1 plus is 1. Means actually we will assume x minus 1 and x minus 2 both are 0, because as an initial value. Okay, so what is that? C0 is the code bit 0 at time instant j, right? Or 0. So this is actually nothing but code bit 0 at time j equal to 0, right? Okay, what is C1 0? Means code bit 1 at time instant 0. It's nothing but x0 dot x minus 1 and minus 2, right? So minus 1 plus, it was j minus 1 and j minus 2, so j is 0, so minus 2. So we are assuming that x0 equal to 1, we know 1 plus both of the values, initial values are 0 0, which is 1. Okay, we can have these values. Okay, the next sequence, for example, C 0 1. code bit 0 at time 1. So x1 plus x j minus 2. So it will be minus 1. Huh? J is 1, minus 2. 1 minus 2 is minus 1. So x1 is what? X1 is 0. Huh? X1 is 0, and we do not know x minus 1. So initial value is 0 is 0. So what about C11? It's nothing but x1 plus x j minus 1, which is 0, x0, and x minus 1, right, which is j minus 2. So we have x1 is 0, x0 is 1. You see x1 is, x1 is 0, x0 is 1. Huh? X0 is 1 plus 0, which is 1. Similarly, we can find the next values. So for example, C0, 2. So x2 plus x0, 1 plus 1 equal to 0. You see 1 plus 1 because this is XOR. Okay, so C1, 2 is nothing but x2 plus x1 plus x0, which is 1 plus x1 is 0 plus x0 is 1. X2 is 1. X2 is 1 here. You see, which is, so 1 plus 1 is 0. Similarly, generating all the, how many bits we actually, our bit sequence, 1 2 3 4 5 6 7 8 9 10. So we have 10 bit sequence, right? So for like repeating this, C0 values will be, C0 values are what? C0 values are 1 1 1 C0, sorry, C0 is 1, C0 is 0. This is not not this. So C0 value is 1 0 0. Okay, so 1 0 0 1 1 1 1 0 0 1. I'm not repeating for all the cases. So we only repeated 3 stages, so we can figure out rest of the one. And C1 will be 1 1 0 0 0 1 1 1 0 0. So here you see there are 10 bits here. For 1 there are 10 bits, so there are 20. So what will be our rate? Our rate will be, it is nothing but, our information bit was 10, our code bit is 20, so it's nothing but half. It's always in convolution, rate is always half. So now why we are calling it convolution code, and that's actually a question. Why convolution? Why convolution? Why convolution? Why we are make this term as a, so okay, let us see how. So C0j is what? Is nothing but xj plus xj minus 2. J minus 2. So if I write it little bit extended, so 1 into xj can write. So j minus 1 is missing, so I had to multiply with 0 0 x j minus 1 plus xj minus 2 plus 1 into xj minus 2. So if I can summarize it, that this is our uh, h0. So this is our h00. This is our h h01. This is our h02. This equation can be right as a summary. Okay, k equal to 0 to 2 h0k into xj minus k. Isn't it? So for instance, for the first one, k equal to 0, so h00, so h00, which is actually 1 in our cases, and x j minus k equal to 0, so xj. So by it can be expressed as this series of this one. Here we can see this is a equation of convolution equation, right? This is a, or convolution operator. Convolution. This is a convolution, and you see this h0, h00, it was 1 in this case. So h01 is 0, and h02 is 1. This is nothing but the filter for this convolution. So this is nothing but the filter h for the convolution, for the convolution, isn't it? So here we can see that our input sequence goes through this convolution filter. As a result, the output code word is generated. Same thing also for we can write it for C1j, C0j, so C1j. So xj, the formula is plus xj minus 1 plus xj minus 2. We can write it 1 into xj plus 1 into xj minus 1 plus 1 into xj minus 2. Same thing here. This is our h0, h10. This is nothing but our h11. This is nothing but actually the h12. So we can write it as a summary, that okay, k equal to as a summation of sum of h1 k x j minus k. Same thing, the same interpretation. This is a convolution. This is a nothing but a convolution. So we can say filter h for the convolution. So here we can write actually that these are filter for code bit stream 1. This is filter for code bit. This is filter for code bit 1, 0, and these are h10, h11, and h12. These are the filter for code bit 1. Okay, so we actually derive the two convolution filter parameter h, or like individual filter parameter, and we can know that, okay, the bit stream, this one bit stream, this bit stream will be the input of this filter, and as a output this code sequence will be generated as a code, this C0 or C1, this code sequence will be generated. Okay, so by this example we actually know about the how this convolution works. Okay, so now we will discuss in these topics, we will discuss a new topics about the matrix representation of this convolution code. So matrix representation of convolution code. Okay, so here actually we will try to get a generator matrix. That's actually our aim. What is generator matrix? We will see. We will try to find a figure out generator matrix. That is actually our goal, or our aim to have it. Okay, so we will try to get a concept of the generator matrix. So let us uh, again consider a bit sequence. Okay, consider bit sequence which is x0, x1, x2, right? X0, x1, x2, x3. Okay, now we like to put it as a row vector, so we will like to something, we will like to put it in a row vector, x0, x1, x2, x3, and x4, blah blah blah. Okay, so this is a row vector here. Of course, in our row vector, which is this one, we will actually multiply with this series of uh, series of x zeros, the bit sequence. Okay, so we'll actually, what we will do, we'll actually write a matrix. Okay, so we will create a matrix. So we will create a matrix. We will create a matrix with x as its column. So if we want to create a matrix, then x will be its column, means actually x0, x1, x2, x3, x4, so on. Okay, now let's just try to create a rows and columns. Okay, okay, here we will write our this c0 values, c00 and c10 in this column. Okay, okay, so then c01, c11, and c02, c12, c03, c13. Okay, so here we will try to fill up this column based on our previous formulas, how we figure it out. We actually still assuming that we still do not know these values, x minus 1, so preliminary values will be taken x as 0. Okay, so because we do not have these values, so we will assume this is a preliminary value. Okay, so c 0. C0, put it in our what is the x0? X0, C0, x0. X0 is 1, right? So C0, x0, 1. Other values are unknown. So we do not know its values. So we put it in the 0. In the same way, C1. So actually, what formula we are using? This formula. Okay. Our previous values formulas. This one. C0, C00, and C01. You see, C00 and C01. All those values here. C00, C10, C10. Okay. For our cases, uh, so 1 1, so 1 1. Okay. So 1 1, and other values are automatically got 0 because they are unknown state. Now C01. What is C01? C01. Okay. C01. For C01 is x1, 1. So x1 is 1. Okay. So x0 will be 0. Other values are 0 because they are unknown. Same thing will happen that x11 will be 1 and x01 will be 1, right? And other values will be 0. There is a pattern actually emerging here. We'll see. Again, C02, C02. So C02 will be the 1. Other values are 0 and 1. And we know this is 1. And from the formula, we find this 1 and 1. And other values are 0. Do not know it. Okay. C03. So values are 1 and other values are 0, 1 and 0. From our previous formulas, also this will be 1 and 1, 1, 0. Here we have noticed that this pattern is actually repeating here, because here you see this state, I mean this condition is the previous, this is the previous condition, and then this is the previous condition. Same thing happens also here. You see 0, this one is actually here, yeah. Also this one is actually here, because their previous is still, we know this is 0, 1, 2, 3. So as a subsequent so we actually create a matrix of these columns, right? So we will write that this is actually our generator matrix, this one, the one we just created. So this one is actually our generator matrix. So what we also notice that the block shifted downwards, like here. You see the block is shifted because it's the next values. The block shifted downwards by every time instant. Right? So the block shifted downward wards by every time instant, by every time instance. What else we notice here? Okay, now we actually our input information, which is our bit sequence, this one x0, this is actually a vector. So we assume, okay, this vector is represented by this x. x. Okay, x x vector. This is actually our generator matrix G, which is we generated just now, is equivalent to the code, which is actually our C vector. That's actually we found from here that anytime you pass your mat, your information sequence or vector through this generator matrix, we will end up to generate your code. Okay, so this is actually our output code word. Output code word vector actually, because we create a matrix. This is G is the generator matrix. Generator matrix, and this is actually our information bits sequence or vector or input information vector, actually information bit vector, info bit vector. So whatever we have actually discussed earlier, that okay, what in convolution, what we do, we actually use a filter so that the information pass through this filter and creates the code word. Same thing actually, the information actually is going through the generator matrix and creates this code word in other word actually. So this there actually the practical scenario how this codes generated, this C code generated. Okay, so this is how the convolution code, by using convolution or generator matrix, how your code is generated from a bit sequence. Thank you then, end of our, this is the end of our this topic.